CERN is the birthplace of some of the world's best-known inventions: the Hadron Collider, which is the world's largest particle accelerator, antimatter, the World Wide Web, and large-scale production of aerogel. Aerogel is the world's lightest solid. Around 99.8% of this material is air, making it an excellent insulator. Aerogel nanotechnology has been used in spacecraft and spacesuits, on a Mars rover, and it's even been used to capture comet dust. Aspen Aerogels embedded tiny particles of aerogel into fibers to create flexible insulation blankets for buildings. This material is 5 times better than standard insulation. So, how does this fascinating material work? Can we use this to build super insulated structures to cut down our energy bills? Will it revolutionize construction, or are there barriers preventing mass adoption? Aerogels are solid gels with pockets of air instead of water. It's often called frozen smoke because of its translucent blue appearance. Silica aerogel is made of 4 main ingredients: tetramethyl orthosilicate or TMOS, methanol, a volatile, colorless and flammable liquid, deionized water, which is treated to remove all positive and negative ions, and ammonium hydroxide, a catalyst that speeds up reactions. Aerogel is an incredible invention with many advantages. It is lightweight, elastic, it can be formed into any shape, and it has superior thermal and acoustic insulation power. However, since it's mainly made of air, aerogel is very brittle and fragile. You can see hairline cracks in this aerogel sample when it's held up to a light. It also easily crumbles into dust, which limits its uses in most applications. To make aerogel more resilient and versatile for the construction industry, tiny silica aerogel particles are embedded into a flexible fabric made of polyester and glass fibers. This creates a space-loft insulation blanket. These fibers are also called a non-woven batting material. They are bonded together with the help of heat, pressure, or chemical binders. They provide a flexible and durable support for aerogel particles and turn a fragile material into a useful product. Aerogel insulation blankets are sold in 2 thicknesses, 5 mm and 10 mm. It's stiff but pliable. It can be cut on-site or in a factory with scissors or razor snips, and it can be easily shaped to fit around pipes, ducts, wires, or other irregular surfaces. It's great in complex and tight spaces and even spaces with restricted access. It gives off a slight smell of ammonia and it leaves your fingers feeling powdery and dry, but it is not toxic in small quantities. Let's jump into some of the many advantages of aerogel insulation. Aerogel insulation has an R value of 10.3 per inch, which is much higher than R 2.7 per inch for fiberglass insulation, R 3 per inch for Rockwell insulation, and R 5 per inch for XPS or extruded polystyrene insulation. Aerogel is very effective at slowing down the transfer of heat from exterior surfaces to interior surfaces and vice versa. It can stop thermal bridging, lower heating and cooling costs, and reduce energy consumption in buildings. If you want to increase the value of the wall, you can simply add more layers on top of the first layer. Aerogel actually has a higher R value than air. This is because of the Knudsen effect. When gas is trapped in very small pores, its thermal conductivity falls below what it would be in free environments. Space-loft aerogel blankets are treated with compounds to make them super hydrophobic or water repelling. When I poured water on the sample, it beat it up and slid right off. Not a single drop of water was absorbed. This water repellency prevents rust and the growth of mold and mildew. Another advantage is its thin space-saving profile. I spoke to an engineer recently that used aerogel insulation on a building in New York because the architect forgot to include insulation in their construction drawings. Since they couldn't rip out the walls and start over, the most economical choice was aerogel. Aerogel insulation is also fire resistant and has a Class A fire rating. It can withstand temperatures from -200 degrees Celsius or -390 degrees Fahrenheit to 200 degrees Celsius or 390 degrees Fahrenheit. Aerogel blankets can be used on internal and external walls, floors, terraces, curved walls, balconies, roofs, and more. It is compatible with most building materials. It can be glued to the underside of wood plank flooring. It can be attached straight to drywall without another membrane. Decorative metal finishes can be added to the wall systems for interior walls. It can also be glued directly to structural, solid wood framing members. One of the most important advantages of aerogel insulation is its breathability. It is vapor open, meaning that it allows water vapor to pass through both ways, which makes it ideal for historic buildings. It has been used on curved surfaces, on historic old mills in Switzerland, a multi-family house, a church, country house, and more. Of course, like every building material and system, it has some disadvantages. Before we discuss them, I'd like to introduce the sponsor of this portion of the video. Brad Hedges is an architectural sales consulting company based in Georgia. They help designers specify terrazzo, stair threads, railings, pavers, and resin wood laminates for architectural applications. They specialize in high-end residential and commercial projects like the Ascent Beech Tree in Atlanta, Georgia. Warm and highly durable Parklex flooring was used in the lobby areas. To complement the wood, removable pavers from Hanover were used in the outdoor areas. Head to bradhedges.com to check out their detailed, exquisite work and contact them for your next project. Let's end this video with the disadvantages of SpaceLoft aerogel insulation. First off, it is very dusty. It is not toxic in small quantities and it can be easily washed off your skin and clothing. However, inhaling large amounts of the silica dust can cause irritation of your throat and lungs. You must use gloves, eye protection, and a dust mask while installing this product. The other disadvantage is the cost. The exact price depends on your location and the quantity being purchased, but in general, it costs around $7 to $20 per square foot, much more expensive than traditional insulation like rock wool, which costs around $2 per square foot. This is the biggest hurdle to mass adoption. Aerogel insulation is a novelty specialized product. Like we discussed in this video, it has superior thermal performance. It is resistant to compression despite being flexible. It's also resistant to moisture and fire, and it can lower heating and cooling costs. It is perfect for historic renovation projects and industrial applications, but not for standard construction. Scientists are trying to lower the cost of aerogel with new ingredients and processes, so watch out for innovations in this space. I came across an all-natural aerogel inspired by wood, a transparent aerogel for windows, and even bricks filled with aerogel. I can make another video on those innovations if you're interested, so let me know in the comments below. Also, check out my dedicated video on aerogel. I'll link it in the description and up here. I'll also link my Patreon page in the description. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button, subscribe button, and the notification bell too. Thanks for watching. See ya.